I would like to start with the first slide. So my name is Sebastian Taubner. I'm working for Moonshiner as a developer. And today I talk about the continuous integration and delivery with Shopware, and also especially about integration into Backstage. So a tool we will hear about today. So to give you an outline of what we will talk about, at first we have the CI/CD part of it. This consists about how could this look in the context of Shopware, so a shop system, because maybe there are some differences, or like just in the case of Shopware, how to do this. Also, which part the GitHub API and the actions play, and then we come to the integration with Backstage already, where we will hear about what is Backstage actually, because there was, I guess not everyone will know about this, and also how does it work, and yeah, our integrations we have so far. And at the end, yeah, there will be time for questions. So let's start. First of all, I will show you some code and how we do this, and how could this look for Shopware, such a continuous integration part. So first of all, what you want to do is maybe lint your code, analyze it with static analyzers, or also the pull request title, because maybe some of you have heard there is something like the semantic releases and versioning, and it's really handy, so you can automate a lot of stuff. And yeah, let's start with this one. So what we see is a GitHub action. It runs on GitHub, and it just consists of three main parts. That's the name, the trigger or the event, and also the jobs. So what should be executed then in an automated manner. And here we see like a semantic link will happen for the pull request title every time someone opens or edits the pull request, which is then, for example, the title, and then it will run on a self-hosted runner and execute an action. So in this case, the semantic pull request. We provided a token, and it will result in like a failing or a successful job. And this way, you can ensure that all your developers develop in the norm. So this was an easier one. The next one will be like build your container, because if you think of Shopware, you want to extend the shop with plugins, you want to modify it, and what you also want to do is maybe run tests afterwards, and for all these steps you need a running instance. And what we see here is the simplified action. So you can see we download an image. This is made for testing, developing, also deploying from the friends of Shopware, and we check out the code. So this one is needed so that we can use it later on. Copy the plugins and start the database. So now we have all the stuff done we need to do the following steps. First one would be a plugin verification. So for Shopware, as mentioned, there are plugins to modify it, and what you don't want is like deploying to production, or maybe also for your, I don't know, clients or for yourself to test it on a testing server, and when you try to update or install your plugins, you get errors. This can happen because of a number of reasons. Faulty configurations, faulty data state, so if you have migrations and there is something missing and yeah, like not considered, then you will get errors. So what you can do is run an action which installs the dependencies. So you install everything for the plugins via Composer, and afterwards install the plugin. What you then can do is like repeat the steps. So you really make sure you can install, uninstall, update your plugins without any errors. So if this, for example, would cause an error, the whole building would fail, and you get a notification on GitHub like, yeah, your build is failing, there is something faulty, look again at the code. Yeah. And this is before you even deploy it, so, and this is the preferred state, because then you can do actions, you're not stressed because there is something broken on production or also on a test server where others want to test their code. And so the next step for doing this would be like uploading the artifact for later deployments. So since we are on GitHub, and we have multiple steps for this, so it's a pipeline consisting of more jobs, more steps, you have kind of reusable parts. One of these parts would be the plugins itself. So you build them inside a container, you install all dependencies, and then you later can just copy it, SSH it, whatever you want to save them. And GitHub, for example, provides a way. So you zip your plugins and then you just upload them. Also here there is, as you can see, the actions upload artifact. So a lot of work is done by GitHub, for example. And what you can do is like really configure the steps you want to do to get to your deployment, get to your build, and yeah. So also, if you want to deploy it then, you have to define it. What we see here is some kind of semi-automatic way. So maybe it depends on you, on your situation, how you program, how you deploy. You can define it that this will run on like every push, every merge, whatever. You can deploy it. For this example, I use the workflow dispatch. Means you can trigger it whenever you want. Here you can configure a commit hash. So this is required. Means you can just press run with the commit you want to deploy, and this will be like built and deployed. Why you want to do it this way? I mean, if you have like really a fixed working cycle, a fixed cycle of like releasing your artifacts, also testing them, also the working interval, so if you work with Scrum, whatever, then this is really nice. So for this example, the easy way is taken, and also this gives you the opportunity to have kind of multiple teams working on the same project with like irregular release cycles. So you can trigger it, and also the nice way is you have everything then automated. So no developer that forgets to clear the cache after deploying, no developer that forgets to update the plugin or maybe override some kind of config. Yeah, what you can see is this action will download the artifact, so we upload it beforehand, so you can use it. Also, it makes use of the whole plugin build deployment YAML, so everything is a YAML for GitHub Actions, and then it will take a workflow conclusion, so only if the building of the deployment will be successful, the whole thing will be like really downloaded and later on proceeding to the upload, to the deploying. And so this continues, you unzip the artifact, you get the branch name, you need that also then for later steps, and you start the deployment status. So what you here do is like saying start the deployment, and also later on, oops, sorry, and also later on, here you have it, deploy to the server. So deploying can be done in multiple ways, like maybe you know there is rsync, there is SSH. Yeah, you can copy paste it on like many ways. And what you see already here is we make use of secrets, for example. So if you write like your automations, if you like to use the GitHub Actions, you always should check against which kind of events do you use, which kind of triggers do you use, which secrets do you need, because if you have an open source repo or like not a private one, this is like really dangerous because you could expose stuff, but most of the time you have private ones, private repositories, then it's no problem, and also the documentation is really good of GitHub, so you're like pre-warned. And at the end you have the deployment status, which says it will set the result to the output of the whole job. So means you also get a status over the API then later to display this, like, okay, deployment to production failed, or in the best case, it worked. So this way you can also display it, and yeah, this was like a quick, really quick way to show you how does pipeline look, how could it look, can it look in code, but there are more, really more steps to include. So a typical continuous integration is like integrating new code into existing parts of code. So what you want to make sure is that the code is still working. So some of the other steps are like running tests, getting important metrics like SEO metrics, like I guess most of you will know the Lighthouse test, Lighthouse suite. So to run against the page metrics, generate documentation, because also documentation is part of the software artifact you build. Partly for new developers, partly for your shop owner, so that he can use it or work with it. And what you also can do is you can make use of the GitHub features. Like there is stuff like caching. You want to really cache it, so then if you have rate limits, you don't count down the rate limits. You make the actions faster. So like we heard before, one of the pain points are slow tests, for example. And yeah, if your CI pipeline takes forever, if it runs for 10 minutes, most of the developers won't use that instant feedback. But yeah, we'll go for a coffee and never come back now. So you really want to look that this runs fast and performant. Also because you want to motivate everyone to write more tests and better tests. And if the basic setup then is low, you don't want to have it. What you can also do is, for the example of Shopware, that's something we're working on, is running matrix pipelines, so that you don't only have one pipeline. So this was an example of one pipeline. So, but you can imagine that all these steps will be executed with variables inside, and they are substituted by, for example, the Shopware version. So what you then can do is test multiple Shopware versions. But that's something in creation right now. So there's not much code that I can show you already. So, but this would be the integration part for now. Let's talk about the GitHub Actions and API a bit more and what kind of role they have. So the API, as you may have mentioned, recognized, is some kind of central interface. So you need some server they run on, you need hosting of your code, you need runners, and all that is connected over the API. So the actions use the API to set statuses, readout statuses, and you can imagine if you have a build, you want the build information. Is the build failing or not? If you have a deploy, is the deploy failing or not? And also the test status. So you can really take every commit of your code, so like every version, and give it a status and read it out later. This will be important because depending on your setup and on your team setup and working mode, you really need to inform yourself about multiple branches, multiple pull requests. You don't only have one master branch where everything is merged and deployed, but most of the time you have more developers, also more teams working on the same project, and then you want to have an overview of your whole ecosystem, your whole shop, and not only one branch and one version. So the actions are used to run in a semi-automated way. So often they are triggered on every push. You can do that. I would do that for linting and everything. You can also run the tests on every push. You can trigger them. You can also run them locally. But one of the reasons you want to run them automated, if you run them automated, you can imagine your developer don't has to know how to run the test, for example. I mean, of course, your developers will know, but it's really a convenient way. If you just push your code, it gets tested, you get the feedback, and you know, okay, I have to touch the code again, I have to correct it, or phew, everything done, tested, even provided my own tests. Now I have a formal way of proving that my code is doing what it should do. Yeah. The next thing you want to think about is, if you work, for example, on GitHub, you have the code hosted there, all your developers have access, and if you ever have talked with a developer, almost every developer don't like to write documentation, and these steps, these GitHub actions are a really good way of, a descriptive way of providing documentation for your developers. You don't have to go to a developer, explain them, these are our servers, this way you can connect there, that's the way you can clear the cache on this server and that server, depending on how you set it up. But the developer can just open the YAML file for the GitHub action, everything is named and described there, he can go through the steps, he can reconstruct all the deployment steps, the testing steps, the building steps, the linting steps. He knows what to prepare for when pushing code, he knows what will happen in the background when you push code. And that's a really nice way of just keeping your developers up to date, onboard them for new projects. Yeah, that's a thing you want to do. Now the API. So GitHub provides a programming interface, application programming interface, and you can do like almost everything there. So you can store artifacts, which means you have something to save and take it on later steps again. You have reports that you can upload. So if you have builds which are failing, you can also upload and later on download and pass the builds. You can display them somewhere else. You can also cache all your actions. So if you have the GitHub API calls, cache them, don't count down your limit. Also you're faster. You can set statuses for everything. Yeah, that's the role of the GitHub API. So it's really handy. Most of the code providers have some kind of API. Yeah, here in these examples we use GitHub. And now we come to the part where we integrate all that into Backstage. So the first question is, what is Backstage? And we'll hear Backstage is an open platform, which means you can look into the source code, you can contribute, so you really know the internals. It's nice, it's community proof, you can say. Also, it's a developer portal. So what means developer portal? Means that you don't always have to go to the developers and tell them what they need to do, but they can show you what they want, because they can write the plugin, modify the platform, and show you this way what they need to work in a good condition. And that's a huge advantage, because then developers are free to improve stuff and drive stuff, and not only implement stuff what they are told. So this is also really nice. Also motivates to write new stuff there. And Backstage is also a centralized catalog. So most of you who work for IT companies or like have developers, managing developers, they know, okay, they don't only have one web shop. Most of the time they have multiple shops, multiple systems, also multiple systems in the background. And to have an overview can get really hard, because if you have more, also kind of compounded systems, so like systems which are part of other systems, then it gets really messy. So to get an overview of the state, the versions deployed. And Backstage provides a centralized catalog, so you can define entities like web shops, websites, services, so if you have microservices, and keep track of them. Also, it's a single page application, so it's really easy to extend. I am a backend developer, but if I was able to write something for Backstage, so it's really cool. It's a Node.js application with the React frontend, and what that means is, most of the cases, what you do as a developer, you just go there and even don't write code, but only use existing plugins. Or if you want to write your own code, you are given the possibility to provide a database, a SQLite database, register some route in the app, in the first app index, and then extend, for example, the entity page. So the entity page is like representing your software catalog then, and all the entities in there. And this way you can really build up nice systems and get a nice overview. And presentation, so so yeah, how does that work? First of all, before we go to the screenshots, pictures, how does this look? It's really easy. So if you have a software artifact code and a project on GitHub, for example, what you will do is like just integrate this one file there, and that's everything. So again, YAML. So latest after the GitHub actions, your developer knows what is YAML, how to write it, and how to understand it. That's also an advantage because you don't need different formats for that. And then you just define which kind of component is it, which version, so that Backstage understands it. Then also the project repository, the links, everything. You can define also groups, so part of these components are also groups. If you have an organization and you have users, they will occur on multiple places, not only one project. So you can reuse that information later on. And yeah, now to the first integrations we did for now. Everything started with a hackathon, we set it up, and all programmers or developers were part of it. That was really cool. Also a way of playing around with this, getting new integrations, and yeah, having fun with the technology also, which is nice because yeah, it's part of your daily work, and if you have also fun with this, it's really motivating and also nice then. So what you see here is some sample project, and this is the interface Backstage provides you. So here we are inside one component, a web shop component, because most of you will know web shops, Shopware, and yeah. And what you see here, you have everything linked. At first you have different tabs. So for the kind of rough navigation, you have the overview on the first side, you have owners, you have a life cycle, you have links for onboarding, everything. So your developer can hit this page and will be informed about everything. Open pull requests, the status of the deployment, where to find the source code, where to find the documentation, if there are sub-components or dependencies involved. So if he has to consider more than just one repository, for example. And yeah, that's also nice because you don't have to search for the code. You don't have to go to different developers, to your product owner, whatever. Ask, are there more services involved? Where's the documentation? Where can I find the user documentation? Where do I need to update what? And yeah, also maybe I forgot the link to this special server because I only need it once a year, and yeah. So that's the overview. As we see on the bottom, there are, for example, deployments, so you always know, okay, which commit. By the way, this commit links then to GitHub, to the pull request, which commit is deployed on which environment. So in this example, there is test and dev, there's also production, and you can introduce whatever you want. So this is like really done by the developer or the actions. Above you see the sub-components, so for this easy example there is none. If you think of Shopware, most of you, or like a lot of you, will have maybe a kind of monorepo where all your plugins are. If you think of architecture where you have like every plugin in a repository, you can model a web shop and have all the different plugins as components where the web shop is dependent on. Above you see tags, so if you have more components, that to find them, to maintain them, so this is, I hope, also explanatory because it remembers on a dashboard and it's really similar to that. So you can also change and modify this view completely. This is really done by the developers or whoever sets that up. So another integration is for now the runner. So all the runs that take part on the repository will be displayed here. This is also nice because in this view you can filter, for example. You can't do that nice on GitHub even. So, and you see here you have the semantic lint, you have the plugin verification. Later on there would be steps triggered like the testing, the generating of the documentation, but we will see more about that. doing additional performance metrics. For example, what you could do is every time you merge into the master, you want Lighthouse to be executed to get a feeling or even a history if you collect information about the performance of your application, web shop, and all the systems. And you also can re-trigger them, so you don't have to change pages. If you're already on this page, you just need to re-trigger and the run will go again, so that's also nice. So the dependencies is skipped as you mentioned, because in this example they are none. What you also have is documentation, which is also nice. So what we, for example, use here is mkdocs and the tech docs API of Backstage. This way you have an easy way of providing documentation. Also user and dev documentation, because most of the time for the developer you want to include the user and the developer documentation, so give him context how to use something, and then also the documentation how it was done. And for users you want to display just the user documentation, and here you get them rendered already. So all your markdown files you have in GitHub, you can restructure them over the entry point, over the mkdocs YAML file, again YAML files, and display them here, have a common centralized platform where you find everything. Then also the pull requests, again to filter for closed, open, everything filtered by the title, by the pull request number. You see the status immediately, so you can go there, you have the links, and that's something also which is really nice if a new developer comes to a project and he wants to get an overview, okay, what is worked on in this project, what are open pull requests. Maybe you have one developer who has to review a lot of code, then he can go there, get an overview, can filter maybe, and so also this was one of the first integrations there, and it's really handy. It's nice to have an overview. Then also you have code insights. So this is also taken then from GitHub, for example. Okay, you have a project that consists of different programming languages or configuration languages. You have releases in that repository, so your build artifacts, you want to maybe tag them and make releases out of it. Again, you have a README file. So, and this is, everything is customizable. So every of these tabs is made, so you can link it, change the navigation and structure, sorry. You have also the possibility to change the front-end components. So if you say, I want just the first 10 results, or let me filter with a drop-down, you can implement that, you can extend that. That's really handy there to get an overview and have the overview. So what you also can do here is later on, you can also implement triggers. If you have webhooks for your repository set up, you can also integrate all the triggers for Backstage. It's, like I said, really easy to extend with the plugins there. It's TypeScript, so you can really write complex stuff, easy stuff. It's awesome. Yeah. Here are some links. So most of them Backstage and Backstage plugins. Have a look at the plugins, what is already there, because it's really nice if you don't have to implement everything by yourself in the first place. You can do that then, but at first it's nice to have some starting point. Also see and play around with it. You have the links for the API, also the checkout actions and everything that you can reread it, and also what are the arguments, and yeah. So I say thank you for your attention. I hope you liked it. And if there are any questions, you can write me per mail or ask me questions now.